Start.
Good afternoon, one and all. I'm Sharmila A, Assistant Professor, Department of Civil Engineering, Vidyavardhaka College of Engineering, Mysuru. So, welcome to GATE Training 2022 on Environment Engineering. So, in that, I'm concentrating on air pollution. So, in the air pollution, according to the syllabus, what they have prescribed is here we have to concentrate on types of air pollution, sources and impact, air pollution control, air quality standards, and air quality index. Along with that, what is the treatment or control air pollution, and some problems related to this. So, I am concentrating on these aspects like type of air pollution, the sources, its impact, air pollution control, air pollution quality standards, and air quality index. So, definitions. So, normally the definition of air pollution has been prescribed by the Engineers Joint Council (ESA). Presence of outdoor atmosphere of one or more contaminants such as dust, fumes, gas, mist, odor, smoke, or vapor in quantities with characteristics and of duration such as to be injurious to human health, animal life, human plants, or to the property, or which reasonably interfere with the comfortable enjoyment of life and property. So, in this definition, it covers each and every aspects may be related to whom it affects and the quantity and in which form and what happens to the environment. So even similarly, Bureau of Indian Standards has also specified what is the definition of air pollution: presence in the ambient atmosphere of substance generally resulting from activity of man in sufficient concentration, present for a sufficient time and under circumstances such as to interfere with comfort, health, or wealth of person, or with reasonable use of or enjoyment of property. So here it's on different aspects of definition provided by Bureau of Indian Standards. And according to American Medical Association, excessive concentration of foreign matter in the air, which adversely affects the well-being of individuals or causes damage to property. So, pertaining to air pollution, let us know a few definitions of air pollutants. What exactly is the meaning of aerosol? It's a finely divided solids or liquid particles, which is of microscopic size, and usually it is suspended and dispersed in a gas or in atmosphere. So, some examples pertaining to aerosol or dust, mist, fog, haze, or smoke, and size normally varies from zero point 0.1 to 100 micron. And a few examples for aerosols: either it may be dust, mist, fog, or smoke. Cement with it's having a size of 10 to 150 micrometer, fly ash 3 to 80 micron, pollen 6 to 20 micron. And the second air pollutant is a droplet, a small liquid particles of such size and density which falls under a still condition. And also it may remain under in suspension under turbulent conditions. Dust solid particles remain in suspensions and which do not diffuse. And the particles above 75 micron are called as grit, which comes under dust. And less than zero point 0.1 micron, which are affected by Brownian motions, they collide with the surrounding particles, coagulate and flocculate, and increase its size, and due to gravitation force, it settles down. Fly ash. It's a non-combustible particle contained in a few gases, and which is released when the organic portion of a coal is burnt. The size normally varies from 1 to 200 micron. Fumes, very fine solids or liquid particles with 0.001 to 1 micron in diameter. And examples is metallic oxides like zinc oxides and lead oxides. Like what we observed in dust, which coagulate and increase and its size. Even here also, it coagulate, flocculate, and settle down, and also unpleasant and it, gives some smells. Mist. Liquid particles formed by the condensation of vapor or dispersion of a liquid or a chemical reactions. Normally, when the mist is there, so normally the visibility of up to 1 kilometer can be affected. And fog visibility reduction less than 1 kilometer, so that is called as mist. The only difference fog and mist is the visibility with respect to taking 1 kilometer as a standard distance. Smoke is a combination of smoke and fog. So soot, a small agglomeration of carbonaceous particle impregnated with tar, which usually release due to incomplete combustion of fuels. Smoke, a finely divided gas-borne aerosol particles of size 0.001 to 1 micrometer, resulting from incomplete combustion of the fuels and consists of carbon and other combustible materials. So these are some pictures which represent particulate matter, where mist, fog, smoke, and ash comes under particulate matter. So which we can visualize. So coming to the concept atmosphere, normally atmosphere is an insulating blanket which protects the earth, and it softens the intensity of light and also heat which comes from the sun. And ozone, which acts as an protecting umbrella, absorbs dangerous or ultraviolet radiation coming from our suns, and it is bounded due to the gravitation force of earth. So in a composition, if we just observe for a dry and clean air, the composition comprises of nitrogen majorly where 78.909%, oxygen by 20.95%, and argon from 0.93. The remaining are uh, concentration in terms of percentage by volume is lesser, and also it consists of carbon dioxide, neon, krypton, methane, helium, ozone, sulfur dioxide, nitrogen dioxide. The concentration is in terms of percentage by volume is lesser than compared to nitrogen, oxygen, or argon. So the based on different aspects like factors on altitude, atmosphere is atmosphere zones of atmosphere will be of majorly of four different types, and including exosphere is five different types. So first one is troposphere and tropopause, stratosphere with stratospares, mesosphere with mesospares, and ionosphere and exosphere. Temperature graph, just we observe that how the variation of temperature exists with respect to the increase in altitude. So in the x-axis it's the temperature, and in the y-axis it's the height in kilometers. So in a troposphere, as it is observed in a graph, there is decrease in the temperature as we move in a higher altitude, and once the stratosphere layer, so the concentration of a the temperature goes on increases, and in mesosphere again pattern was observed just like troposphere temperature altitude, and temperature on. So this happens here because the
ಸರಿ ಮೇಡಮ್.
ಹಲೋ,
ಹಾ, ಮ್ಯೂಟ್ ಏನಕ್ಕೆ ಆಗೋಯ್ತದು? ಆಯಿಲ್ ಆಡ್ ಮಾಡಿ.
ಅವಾಗಲೇ ಇದಾಗಿತ್ತಲ್ಲ, ನಾನು ಮಾತಾಡ್ದೆ ಅಲ್ವಾ ಅವ್ರ ಜೊತೆ.
ಆಗಿ ಬಂತು, ಮಧ್ಯೆ ಮ್ಯೂಟ್ ಆಗ್ಬಿಟ್ಟಿದೆ ಮೇಡಮ್.
ನಾನೇನು ಕ್ಲಿಕ್ ಮಾಡಿಲ್ಲ. ಆಯ್ತು ಬಿಡಿ.
ಹೌದಾ?
ಈಗ ಎಲ್ಲಿಂದ ಮಾಡ್ಲಿ?
ಈಗ ಮೇಡಮ್, ಈಗ ಎಲ್ಲಿಂದ ಮಾಡ್ತೀರಿ? ಈಗ ಒಳ್ಳೆ ಕತೆ ಆಯ್ತಲ್ಲಪ್ಪ. ಎಷ್ಟು ಸ್ಲೈಡ್ಸ್ ಆಗಿತ್ತು ಮೇಡಮ್?
ಗೊತ್ತಿಲ್ಲ ಕಣಪ್ಪ. ನನ್ನ ಸ್ಲೈಡ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ ಇವಾಗ ಎಷ್ಟು ಸ್ಲೈಡ್ ನಂಬರ್ 16, 17, 18.
ಅದು
ಮತ್ತೆ ಈಗ ಮಧ್ಯಾಹ್ನ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ಈಗ ಎಡಿಟ್ ಕೆಲಸಗಳಾಯ್ತಿದೆ.
ಅಲ್ಲ, ಏನ್ ಮಾಡ್ಲಿ ಹೇಳಿ ಅಷ್ಟೇ.
ಈಗ ಮತ್ತೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಾ?
ಕಂಟಿನ್ಯೂ ಮಾಡ್ಬಿಡ, ಇಲ್ಲ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಅಂತ ಹೇಳಿ.
ಮೇಡಮ್,
ಏನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ. ಒಂದು ಹೊಸ ಕೊಡ್ಬೇಕಾ, ಕ್ರಿಯೇಟ್ ಮಾಡ್ಬೇಕಾ ಈಗ ಮತ್ತೆ?
ಬೇಡ, ಈಗ ಪರವಾಗಿಲ್ಲ, ಇದನ್ನ ನಾನು ಕಟ್ ಮಾಡ್ಕೊಂತೀನಿ. ಈಗ ಇದೇ ಲಿಂಕ್ ಅಲ್ಲಿ ಮತ್ತೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಅಷ್ಟೇ.
ಈಗ ಅಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ, ಕಂಟಿನ್ಯೂ ಮಾಡ್ಲಾ?
ಕಂಟಿನ್ಯೂ ಇಲ್ಲ, ಫಸ್ಟ್ ಇಂದ.
ಆಯ್ತು ಬಿಡಿ. ಓಕೆ, ಕಂಟಿನ್ಯೂ ಇದೆ. ಸೇಮ್ ಅಲ್ವಾ ಲಿಂಕ್? ಏನ್ ನಥಿಂಗ್ ಚೇಂಜಸ್?
ಏನು ಇಲ್ಲ, ಫಸ್ಟ್ ಇಂದ ಅದೇ ಲಿಂಕು, ಫಸ್ಟ್ ಇಂದ ಮಾಡಿ.
ಆಯ್ತು, ಹೋಗಿ ಫಾಸ್ಟ್ ಆಗಿ ಮಾಡ್ಕೊಂಡು ಹೊರಟೋಗ್ತೀನಿ. ಓಕೆ, ಆಯ್ತು. ಓಕೆ, ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ? ಇದೆ, ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ?
ಮೇಡಮ್, ನೀವೇ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, ನೋ ಪ್ರಾಬ್ಲಮ್. ನಾನು ಎಕ್ಸಿಟ್ ಆಗ್ತೀನಿ. ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ.
ಓಕೆ, ಸ್ಕೂಟಿ ಸುಮ್ಮನೆ ಅಲ್ಲಿ ಓಡಾಡೋದು ಕಾಣಿಸ್ತು. ಓಕೆ, good afternoon. Welcome to GATE Coaching, Environment Pollution on Air Pollution by Shamla A, Assistant Professor, Department of Civil Engineering, Wastewater College of Engineering. Normally, air pollution syllabus, which covers type of air pollution, sources of and impacts, air pollution control, air quality standards, air quality index. So I'm concentrating on types of pollution and sources and impacts. So definition, according to Engineers Joint Council USA, presence in the outdoor atmosphere one or more contaminants such as dust, fumes, gas, mist, odor, smoke or vapor in quantities with characteristics and of duration such as to be injurious to human health, plant, animal life or to the property, or which unreasonably interfere with the comfortable enjoyment of life and property. So Bureau of Indian Standards, according to the BIS, the definition says presence of ambient atmosphere of substance generally resulting from activity of man in sufficient concentration, presence of sufficient time and under circumstances such as to be interfere with the comfort, health or wealth of person, or with reasonable use of or enjoyment of property. So according to American Medical Association, excessive concentration of foreign matter in the air which adversely affect the well-being of individuals or cause damage to property. So let us know a few air pollutant definitions. Aerosol is finely divided solids in either liquid particles, which is of microscopic size, suspended and dispersed in gas or in atmosphere. So examples are dust, mist, fog, haze or smoke. The size normally varies from 0.1 to 100 micrometer. And cement with 10 to 150 comes under aerosol, fly ash 3 to 80 micron, pollen 6 to 20 micron. A droplet, a small liquid particles of size and density that it falls under still condition may remain under turbulent condition. So dust, solid particles which is remain under suspension but do not diffuse. Particle normally varies from 75 micron, usually called as grit, which comes under dust. Less than 0.1 micron meter of a dust affects by the Brownian motion. So when they collide with the surrounding particles, it coagulates, flocculate, and then due to gravitational force, it settles down. Fly ash is a result of the burning of organic portion from the coal. It is non-combustible particles contained in the flue gas. Size varies from 1 to 200 micron. Fumes are very fine solid or liquid particles with a size 0.001 to 1 micrometer in diameter. The examples are metallic oxides like zinc oxide, lead oxide. So even here, like a dust, it coagulates, flocculates, settle down, and also it is unpleasant and creates some smell when it combines with the other component. Mist are liquid particles formed by condensation of vapor or dispersion of liquid or a chemical reaction. So applied when a droplet in the air, where visibility has a value of up to 1 kilometer or more. So fog is same thing, just like a mist due to the liquid particles present in atmosphere, but the visibility reduction is lesser than 1 kilometer due to mist. So smoke is the combination of smoke and fog. So normally, if we take an example of Delhi, so normally smoke is a best example in Delhi due to the presence of liquid particles through natural phenomena, and combined with the smoke released from vehicles and industrial source. A soot, a small agglomeration of carbonaceous particles impregnated with the tar formed by the incomplete combustion of fuels. So this we can usually visualize. Smoke, a finely divided gas-borne aerosol particles of size 0.001 to 1 micron, resulted from incomplete combustion of fuels, consist of carbon and other combustible materials. So particulate matter. Particulate matter, these are some of the examples of mist, fog, smoke and ash which comes under particulate matter. So this can be visualized. So we know that atmosphere is a blanket which protects Earth, and also it suffers the intensity of light and heat that comes from sun, and the ozone layer which acts as a protecting umbrella from dangerous ultraviolet rays from the sun, and because it is bounded due to the gravitation force of Earth. So if you see the composition of a clean and dry gas or air, so majorly it consists of nitrogen with 78.09% by volume, oxygen by 20.95, argon by 0.93%. The remaining gases like carbon dioxide, neon, krypton, methane, helium, and other gaseous component has a lesser percentage of concentration by volume. So zones of atmosphere can be categorized into four spheres and three pauses, excluding exosphere, troposphere with tropopause, stratosphere with stratopause, and mesosphere with mesopause and ionosphere. So it is mainly based on the altitude. So this picture clearly indicates in each sphere there is variation in a temperature. In the first sphere, like troposphere, as we move in a higher altitude, the temperature goes on decreases. But in a stratosphere, temperature increases. Similarly, just like troposphere, mesosphere, temperature goes on decreases with the increase in altitude. But in a thermosphere and ionosphere, the temperature goes on increases. This is because of the changes that occurs and the reactions that actually occurs in each sphere. In a troposphere, normally vigorous changes in atmospheric condition. The temperature goes on changes with the altitude. But in a stratosphere, due to presence of O3, that is ozone, which has the capacity to absorb the ultraviolet radiations coming from the sun, and it re-radiates back. So there is increase in the temperature in a stratosphere. In a mesosphere, just like a troposphere, due to the various the reactions that occurs in the atmosphere, mesosphere, normally the temperature decreases with respect to the altitude. In a thermosphere, again the chemical reaction, but is exothermic in a nature, which releases enormous amount of heat. So there is increase in the temperature, and also presence of many ions, just like in a thermosphere and ionosphere, and enormous heat is released. So increase in temperature beyond thermosphere in an ionosphere. So scales, the main parameters that govern the change in the atmosphere are heat and temperature, pressure and cyclone, wind direction and wind speed, moisture and humidity, rainfall and precipitation. The scales of meteorology can be divided into three. One is macro scale, meso scale, micro scale. So, whatever the changes that occurs globally or continentally due to the movement of air masses, and that is continental dust storms, cyclones, and winters, so we consider that comes under macro scale, and meso scale, which is confined to the regional changes like heat island effect, sea breeze, and micro scale, which usually the changes occurs in a local environment, that is pollution from chimney or industries. So let us know the first questions which may appear in the competitive exams. The Central Pollution Control Board standards for NO2 for sensitive areas. like exposed limit at atmospheric pressure at 25 degrees centigrade, are given as 30 microgram per meter cube at 1 atmospheric pressure at 20 degrees centigrade, expressed the concentration in 1 ppm in ppm. So we have to convert that in microgram per meter cube to ppm. So for that conversion, we should always remember this one. 1 mole of an ideal gas at 1 atmosphere and 25 degrees centigrade occupies a volume of 24.45 liters. So NO2 standards for calculations, the molecular weight of NO2 is 14 plus 2 into 16, because 2 moles of oxygen. So it comprises of, totally comprises of 46. So for conversion of ppm, ppm of NO2 is this formula also we should remember, because in the previous we came to know 24.45 liters volume it will be occupied. 24.45 into 10 to the power of minus 3 meter cube per mole into 30 into 10 to the power of minus 6. Here they have given the concentration as 30 microgram per liter. So 30 into 10 to the power of minus 6 gram per meter cube by 46 is nothing but the molecular weight, 46 gram per mole. So it gives answer as 0.016 ppm. A car emits a carbon monoxide as exhaust gas by 2% by volume. Calculate the concentration of CO in microgram per meter cube. So here we have to convert by 2%, calculate that in microgram per meter cube at 0 degree and 25 degree at 1 atmospheric pressure. So 2% by volume of carbon monoxide is nothing but 20 ml of carbon monoxide in liter of air. That's 20 ppm. At 0 degree, 1 ppm of CO is equal to 28 by 22.4. 22.4 is a conversion factor. So what we observed in the previous slide, into 1000 microgram per meter cube. So it gives 1250 microgram per meter cube. But here it is for 1 ppm, and for 20 ppm of carbon monoxide, 1250 microgram per meter cube into 20 gives 25,000 microgram per meter cube. So normally air pollution will be categorized into urban and rural. So in an urban area, major sources are vehicle, industrial industries, and in a rural area, it may be a biomass burning or pesticides. So with respect to vehicular pollution, the pollutants like NOx, SOx, carbon monoxide, particulate matter, volatile organic compounds, phenolic components, trace metals. From industrial sectors, it may be carbon monoxide, SOx, NOx, particulate matter, trace metals. And from biomass burning, NOx, SOx, CO, particulate matter, VOC, pH, trace materials. And from pesticides, organic component, carbon components. So all this may be released. So normally classification of air pollutants are different types. So broadly it can be classified based on its origin or chemical composition or state of matter. So according to the according to origin, so air pollutant can be classified into primary and secondary pollutants. Primary pollutants are nothing but those which are released directly emitted from identified sources. So they directly emit to the atmosphere. Example is particulate matter, oxides of nitrogen, oxides of sulfur, carbon monoxide, radioactive components. So secondary pollutants are those that are produced, which are produced in the air by the reaction of two or more primary pollutants. Example, ozone combines with O2, nascent toxin combining with oxygen, formaldehyde, photochemical smoke, peroxyacetyl nitrate pan. So all these are examples of secondary air pollutants. According to chemical composition, so it can be classified into organic pollutants, inorganic pollutants. The organic pollutants are the containing carbon and hydrogen components. So example are hydrocarbon, aldehydes, ketones, alcohols, organic sulfur compounds. And inorganic pollutants, which includes carbon monoxide, carbon dioxide, carbonates, oxides of nitrogen, sulfur, ozone. So according to state of matter, the third category or classification, natural contaminant, particulate matter, gaseous and vapor. based on a position. So the other way of classification is whether it is stationary or mobile. So this includes a point source like large stationary sources, just like an industry, area source, a small industrial sources like or residential heating, mobile source, a line source like a movement of vehicle in a highway, or a source like aircraft at airports. So point source, a few pictures depicting points and area source and mobile source. So effects of some common air pollutants. If we just take an example of particulate matter, it has huge effect on human beings, animals, and materials. On human beings, because the size lesser than 1 micron causes lung damage. Asbestos fibers can causes cancer, and due to automobile exhaust affects the brain. Lead from automobile causes several respiratory disease, like maybe it may be due to silica, arsenic, it causes cancer. Effects on plants, the particulate matter, which is very toxic in nature, affects the growth of plants, and also it may blocks the stomata, which reduces the growth of plant, and also it reduces due to the acid rain, reduce the pH of the soil and makes it infertile. Effects on materials, particulate can damage even the buildings. The corrosion is one of the major problem if the concentration of particulate matter is very huge. Causes cracks and fading of the surfaces, and accumulate in soil and reduce the fertility of the soil. So best example is Taj Mahal. Carbon monoxide effects on human beings. Normally, high concentration causes sometimes leads to death. Concentration of carbon monoxide, the formation of carboxyhemoglobin will be absorbed when concentration of CO enters human blood, and hence reduce the carrying capacity of the blood. At the concentration of 100 ppm, people experience dizziness and headache. And cigarette smoking usually consists of 400 to 450 ppm of carbon monoxide, the percentage of COHP, that is carboxyhemoglobin, in a blood of a cigarette smoker increases with increase in smoking. And the concentration, if it exceeds 750 ppm, death may occur. On a plant's CO reduce nitrogen fixing capacity of the bacteria, which affects the plant growth in a soil. High concentration causes leaf drop, reduces the size of the leaf, and aging. Effects on materials. Carbon monoxide appears to have a no detrimental effect on materials. Oxides of sulfur on a human beings, it causes an irritation to eyes and respiratory tract. Increased SO2 concentration in atmosphere may also lead to lung cancer. SO2 may also obstruct the breathing, and SO2 also leads to formation of H2SO4, which is 20 times more than it tend to SO2. Effects on plants, low concentration for longer period may cause discoloration of leaves. SO2 affects the growth of plants. At high concentration, leaf tissue get damaged. H2SO4 is extremely toxic to plant and soil fertility. Effects on material. Sulfuric acid, which attacks the building materials containing carbonates. This may form calcium sulfate and gets easily washed away, leaving a discolored surface. And paper also absorbs SO2, causing a paper to become brittle. Leather loses strength and flexibility. Oxides of nitrogen on human health, reduces oxygen carrying capacity of the blood. Nitrogen dioxide causes irritation to lungs, and high level of NOx causes pneumonia, lung cancer, oxygen deficiency. Extremely dangerous, and also cause irritation to respiratory tract, nervous system, and digestive tracts. Effects on vegetation is a primary pollutant can damage a plant tissue, and high concentration also damage to the leaves. Secondary pollutants like smog, like ozone, may damage the vegetation. And effects on materials: if nitric acid causes corrosion to the metallic surface, fades the colors of cloths, and cracking of rubber. Hydrocarbons, aromatic hydrocarbons may also sometimes lead to cancer and irritation to respiratory tract. Methane, which is narcotic effect on create narcotic effects on human beings, and also it is carcinogenic to lungs. On the vegetation, it affects the plant growth, discoloration of leaf, and on the materials, discoloration of the material becomes less and becomes brittle. So these are some of the impacts of air pollution on plants. So there are some technical or mm, words which you should understand. That is bifacial necrosis, pigmented lesion, epinasty, acute injury, chronic injury, chlorosis, abscission, and necrosis. These are based on the different types of problem that arises in the plants. Harmful effect of air pollution on materials. Um, a stone, marble get affected due to sulfur dioxide, and discoloration may happen. Metals and reinforcement due to presence of SO2 or acid fumes gases, and rubber get affected, like cracking may occurs due to ozone and oxidants. Paper and fabrics get discoloration and embrittlement due to acid fumes and gases. So, question which may appear in a competitive exams: two primary air pollutants are. So, based on the concept what we learned, which is considered to be a primary, which is directly emitted from the source. So, here is C, sulfur dioxide and hydrocarbons. The ozone is a secondary pollutant. Peroxyacetyl nitrate is secondary, and so hence sulfur dioxide and hydrocarbon. So, let us move to the next concept: temperature lapse rate. So, in a normal dry adiabatic condition, so this is a condition where when a, normal atmosphere with specific temperature, the movement of flume will be in a vertical manner. So, let us consider what exactly is the meaning of dt by dz. It's nothing but small change in a temperature with respect to altitude. It's given by dt by dz is equal to minus n minus 1 by n into r. So, in a picture, let us consider a small portion of an air parcel. It is moving in a upward direction in a vertical manner. So at a normal dry atmospheric condition, this is the condition. Means in a previous graph, we observed that as we move in higher altitude, the temperature goes on increases. So that the same has been depicted here by giving the equation dt by dz is equal to minus of n minus 1 by n into r. So normally in a dry adiabatic lapse rate, the changes or the decrease in temperature is 0.01 degree per every meter. So negative symbol represent decrease in temperature with respect to an altitude of 1 meter. So environmental lapse rate ELR is nothing but due to changes that occurs in an environmental condition. So how the behavior changes. So this DALR and ELR is very important in understanding the dispersion of a pollutant in atmosphere. So these different types of ELR with respect to the DALR conditions. So let us take know one by one. In the right, like high stable inversion condition, when n value with respect to the previous equation what we observed, when n is less than 1, we consider that as inversion condition, that is highly stable. So in this condition, normally dispersion of the pollutant is very difficult because it is stable in a nature. When n is equal to 1, we call that as condition as isothermal. And when n lesser than 1.4, normally we call this as sub-adiabatic condition, which is little bit good for dispersion. And when n is equal to 1.4, we call it as neutral condition, where the pollutant release in a vertical manner. So in a neutral condition, normally 1 degree centigrade for every 100 meter. So decrease in temperature of every 1 degree centigrade for every 100 meter. When n greater than 1.4, we call that as super adiabatic condition, that is unstable in nature. Soon after there is release of air pollutant, the dispersion of pollutant immediately get dispersed. So it is with respect to the temperature, considering the altitude. Inversion. So let us know what is inversion. You can observe here in the graph at the starting point from a ground floor. We observe that in a normal DLR condition, the temperature has to decrease with increase in altitude, but it is a reverse condition where the temperature is increasing and with respect to the altitude. So if this is a condition, normally at that layer till where it is behaving in opposite to the DLR condition, that height we can consider that as layer of inversion, where dispersion is very less or doesn't take place. So when an air pollutant is released under this condition, inversion condition, normally dispersion will not take place. So this type is called as radiation inversion. So these another two types, that is subsidence inversion. So here what happens at the ground floor to certain extent on altitude. So the behavior of temperature is exactly just like a DLR condition, that is decreasing with respect to altitude. But in between, so as it move, again it is in an inversion condition, increase in temperature, and again in a higher altitude, the temperature behaves just like a DLR condition. So it's nothing but just like a sandwich in between the two um, DLR condition. So that layer where inversion occurs, that is called as zone of warmer air. That is nothing but inversion layer. So it's just like a sandwich. This condition is still more worse. Normally, subsidence inversion will be observed in a hilly places or valleys. So where the land get eat up at the ground floor and temperature as we move higher goes on decreases. But in between, due to n number of activities, release of pollutants, and the atmospheric condition where the temperature is lesser. So there the layer of inversion condition exists. So the pollutant released from valleys will not easily get dispersed. It is held at the same place. So this is actually worst case. Normally at the time of winter season, along with the release of pollutant if it's higher, then the scenario is little bit worse. Double inversion is a combination of both radiation inversion and subsidence inversion. So in between, we'll see the presence of layer of inversion. So fume behavior. Fume behavior can be considered different types. One is looping, coning, fanning, lofting, fumigation, and trapping. So this is nothing but the behavior of plume with respect to the environmental condition and release of plume from stack. So how the behavior changes with respect to the environmental condition. So this is nothing but the effect of inversion on plume behavior. So we came to know that what is actually inversion, increase in temperature with respect to the altitude. So this happens when the stack, the pollutant or air pollutants having a lesser temperature compared to the surrounding temperature. So that will not allow the pollutant to disperse, and the dispersion altitude is very less. Looping, this is the first condition. Usually this occurs at a warm season with a clear skies where the air is turbulent in a nature, and this is called as unstable condition. Usually when a DLR n value lesser than 1.4, greater than 1.4, unstable condition. Soon after the release of pollutant, normally the dispersion of pollutant will be in the form of a loop. And but normally what happens if the height of the stack is lesser, then looping will affect, the looping condition will affect the nearby ground air, nearby ground with a higher concentration of air pollutant. coning. So this occurs in a stable condition where and the moderate wind usually occurs at a night time at the cloudy or wet climate. So just if we just observe the concentration of the pollutant released from a nearby stack, it affects the area very near to the industries because the pollutant concentration is moving in a cone shape form where the concentration in the downstream is higher. A fanning, usually if we observe the plant, it is moving in a turbulent manner, but there is restriction for the dispersion of pollutant in the air. Usually it occurs in an inversion condition at a light wind. This can be observed, the condition may be observed in the night or early morning. So where the heating up of ground level is lesser, and this is also seems to be a little bit worse condition. Lofting, usually, when a radiation inversion occurs below the stack, this condition may be observed. Here, the reaching of pollutant to the ground is little bit lesser. It occurs at the evening time when a clear skies, and this condition is also a little bit worse in the nature. But dispersion in above the stack will occur. Fumigation, worst condition man compared to the remaining. Usually, inversion condition above the stack, if it occurs, it will not allow the pollutant to move in a vertical manner. So it usually occurs in a early morning, early afternoon or late morning when the sky is clear and the wind velocity is light to moderate. So this is worst because it reaches the nearby area downstream to very near to the stack. Trapping, so here the air get the pollutants get trapped between two different condition. So inversion condition at the very near to the ground. So this is also a little bit worse condition. A neutral condition. So when ELR is equal to 1.4, so this condition, the temperature goes on decreasing by 1 degree centigrade for every 100 meter. It occurs in a clear sky neutral atmosphere, and the light is the wind is very light. So it moves in a vertical manner rather than in a horizontal manner. So the nearby areas affected by this situation is very lesser. In an atmosphere under superadiabatic lapse rate condition, the emission from a chimney produces a plume described as so when we observe this, it's a looping. So that we observed in the previous case, this superadiabatic condition. The dispersion of pollutant in atmosphere is maximum when we observe the dispersion of pollutant is maximum. So we observe that correlating with adiabatic lapse rate with the environment lapse rate. So this is when the environment lapse rate is greater than adiabatic lapse rate. So some observation has been done with respect to elevation and temperature, just to ascertain that what is the stability of atmosphere. So elevation at 10, 15.5, 60, 15 degree, and 120 meter, 14.3. So the atmosphere now we classified based on this by observing the elevation with temperature. So here we can calculate this using a formula by taking two different temperature, that is ELR at first and second elevation, 15.5 minus 15 by, so elevation is 60 minus 10, that is the elevation at starting what they have observed, into 10 power of minus 3. It's a conversion factor. So 10 degrees centigrade per kilometer. And ELR condition between 2 and 3rd layer, 10 degrees centigrade per kilometer. Since ELR is greater than adiabatic lapse rate, that adiabatic lapse rate is 9.8 degrees centigrade per kilometer. So atmosphere is considered to be unstable in nature. So answer is second. Source of from this, what we understood is what are the sources of air pollution and what are the types of air pollution. Um, so what are the classification of air pollution? So it can be usually classified based on the occurrence and time and formation. So this and effects of air pollution on human beings, plants and materials. And we also understood what is lapse rate, and with the lapse rate we understood what is DLR and ELR condition, and how this DLR and ELR condition, with the changes that occurs in the atmospheric condition, how it helps in the dispersion of air pollutant in our atmosphere. So keeping this aspects in the mind, one can easily decide that whether the condition is favorable for any air pollutant to disperse. So usually this lapse rate concept will be adopted in finalizing industries or citing of a industries based on the changes, the vigorous changes that occurs in that place due to environmental or weather conditions. So for an huge industries where air pollutant is one of the major pollutant, normally lapse rate with the environmental consideration will be preferred, and based on this condition, so either a concerned authority can either prefer for giving a permission for any new industry to come up or not. So just like what we observe in an industry which is polluting, no, which is releasing pollution in terms of liquid, usually the criteria that what they observe is there any water body to release a treated effluent. So just like that, in for an air pollution polluting industries, the criteria what they observe is for a dispersion whether the environment is good or not. And before dispersion, normally n number of measures has to be taken, like providing control measures, control equipments if it is a particulate matter, and considering absorption technique for if it's in a gaseous absorption or adsorption technique if it's a gaseous pollutant. So keeping all these criteria in our mind, normally the permission or will be provided for locating any industries. So with and also we observed based on a DELR and ELR condition how the plume released from an industries behave. So normally two main criteria we can observe. So because the plume behavior normally varies with respect to the ELR condition. So one first measures what we can take is providing control methods before a pollutant is discharged the environment. And the second thing is the environmental changes that occurs in that particular place, so that we can taking these two criteria we can easily conclude that the air pollution can be controlled with these aspects, considering these aspects before providing a permission for any huge industries which is creating a harm to environment through air pollution. So thank you so much. Thank you, one and all.